Hello and welcome back. I'm Benjamin Williams, and today we're still within the infrastructure section within Boson NetSim. Today we're going to be troubleshooting some MST. So since we're troubleshooting MST or spanning tree protocol, we know that we're dealing with a layer 2 issue in this lab. That's where spanning tree runs at the layer 2 level at the switch layer. So our objective for this lab is to analyze, locate, and fix spanning tree protocol STP problems on your network, which can be caused by misconfiguration or incorrect design. So we have our same topology that we had in the last couple of labs. Have our PCs connected up to our access layer switches. Access layer switches is of course going to give our end devices such as our PCs access to the network. We have redundant connections to the distribution layer switches. Of course, spanning tree is going to block one of those connections to prevent layer 2 loops. Our A switch is of course going to be our STP point in our or layer 2 point in our network. Usually our distribution layer will be our layer 3 boundary, but this is just the lab, so we're most likely going to be running spanning tree on our distribution layer. But in the enterprise network, this will be our layer 3 boundary. It will aggregate all of our access layer switches, and if traffic needs to flow through to another PC on a different subnet, it'll go through our distribution layer. Our core switches are connected to our distribution layer redundant connection as well. We can see some redundant connections from our distribution to our core. Of course, spanning tree is going to block one of those to prevent loops. Our core switches are going to usually be in charge in our enterprise to aggregate all of our distribution layer switches. So if information needs to flow out to our data center, our WAN, our internet, the cloud, for example, our core switches will be in charge of routing that information out to the routers, and then the routers will take care of the information from there. So we've already read through all of the commands and descriptions for this lab. Like I said, we're going to probably be running spanning tree on all of these switches for lab purposes. But that's what we got. We read through all of our commands and our descriptions, like I said. And right here it says our optimized configuration. So it says the information in the table below depicts the optimized configuration that should be running on the lab devices. So we have all of our switches. They should be running MST with VLANs 1 through 3 group as instance number 1. They should also be running MST with VLANs 4 through 6 grouped as instance number 2. D switch 1 should be the primary root bridge for VLANs 1 through 3. D switch 1 should also be the secondary root bridge for VLANs 4 through 6. Same thing right here. D switch 2 should be the primary route for VLANs 4 through 6 and the secondary route for VLANs 1 through 3. And core switch 1 should be the VTV server for all of the switches. Okay, so it says our lab task. It says complex network troubleshooting requires a structured approach. Network documentation that includes thorough troubleshooting procedures can decrease the amount of time required to resolve network problems. Troubleshooting procedures should contain a process to diagnose problems and steps necessary to verify that a proposed solution resolves the problem. In this lab, this is referred to as a troubleshooting and verification plan. So we're going to keep our topology up in the top left as we usually do. We're going to be doing all of our lab readings in the top right, and we're going to be doing our configuration down here at the bottom. So let's go ahead and get into trouble ticket number 1. It says configuration error. It says a network engineer has noticed several problems with packet flow in the network. Verify that ports on all switches are configured to participate in STP and correct any errors you find. Okay, so let's go to A switch 1. Let's do an enable and let's do a show. Let's do a show spanning tree. Okay. So we have MST group number 0, but that's the default. We have MST instance number 1 and instance number 2. So we can see right here that it includes fast Ethernet 04 through 05 for MST number 1. And for MST 2, it only has fast Ethernet 02 through 04. Let's go to A switch 2. Let's do an enable. Let's do a show spanning tree. And let's look. So we can see a difference already within our different configurations. We can see on A switch 2 that it doesn't have the fast Ethernet 04 and MST 0, or it does. It doesn't have the fast Ethernet 02, and it also doesn't have the fast Ethernet 02 in MST number 2. So we're missing that fast Ethernet 02 for both of those. Okay, that's on A switch 2. So right here we can do a show IP interface brief. Okay, we have no IP interfaces configured. Let's do a show interfaces status. Okay, let's do a show. Let's give some context sensitive interface. Can I do trunk? Okay. All right. Let's do a show run. Just give me some different commands so I can see what is going on here. Oh, okay. So I think I know now. We can see that this fast Ethernet 02 connection it has a switch port mode. It's configured as a access port. Okay. And let's see, is it connected to another switch? Let's do a show CDP neighbor. And we can see that the fast Ethernet 02 is what we're looking for. That is connected to another switch. So that will probably need to be a trunk port. We can see that it's configured to be an access port. So let's change that. Let's go into configure terminal. Let's go into interface fast Ethernet 02. And let's do a switch port mode trunk. And let's do a do show run now. Okay, we can see that our interface is now a trunk, which is what we want. And let's do a show spanning tree. Or do show spanning tree. All right, now we can see that the fast Ethernet 02 connection is now back within our configuration, which is what we want. Okay, so that's perfect. Let's go to our D switches now. Let's do an enable. Let's do a show spanning tree. Okay, we can see that it has fast Ethernet. Let's go to MST group number 1 and 2, or instance number 1 and 2. We can see we have number 1, number 2, number 3, number 4, number 5, number 6, number 7, number 8, number 9, number 10 here on the distribution layer switch. So 1, 2, 3. We don't have 4 configured right here on MST instance number 2. So let's check that out. Let's do a show interfaces trunk command. And we can see that our fast Ethernet 04 is not configured as a trunk. So let's do a show run just to see. And we can see our fast Ethernet 04 connection is also configured to be an access layer switch port, which I don't think we want. Let's do a show CDP neighbor. And our fast Ethernet 04 is connected to our access layer switch. So we do not want that to be an access layer port. Only our access layer port should be configured for end devices such as PCs. So let's go into let's go into configure terminal. Let's go into interface fast Ethernet 04, and let's do a switch port mode trunk. And let's do a do show interface trunk now. And we can see our fast Ethernet 04 is now trunking using 802.1q. You can see the status is trunking. So now let's do a do show spanning tree. And we can see our fast Ethernet 04 is now added to MST instance number 2, which it wasn't before. So that's perfect. Let's go over to D switch 2 now. Confirm its configuration. Let's do an enable. Let's do a show spanning tree. We can see fast Ethernet. Okay, fast Ethernet 1, 2, 3, 4, 5, 6, 7, 8, and 9. Same thing down here. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And same thing here. So that's perfect on D switch 2. It doesn't look like anything out the ordinary is going on D switch 2. Let's go to core switch 1. Let's do an enable. Let's do a show spanning tree. Okay. We can see our fast Ethernet 0, 1, 2, and 3 are configured for MST instance number 1, but not for MST instance number 2. So let's do a show interfaces trunk over here. And we can see that our fast Ethernet 0, 3 through 8 are configured as trunk ports. So let's do a show run. And let's see. Okay, so number 1 and 2, they have no configuration at all. So maybe this looks correct. Yeah, this looks correct. Yeah, this looks correct. 3, 4, 5, 6, 7, and 8. 3, 4, 5, 6, 7, and 8. Yeah, that's what we want to see. Let's do a show CDP neighbor. Okay, so we can see our fast Ethernet 0, 2, and number 1 are connected to our router. So those are good. All right, and let's do an enable over here. Let's do a show interface trunk. Alrighty, everything looks to be correct there. Let's do a show run just to confirm. Okay, we can see our fast Ethernet 0, 2, and 0, 1 are not configured. And let's do a show CDP neighbor right quick. And yeah, fast Ethernet 0, 1, and 0, 2 are both connected to our router. So that's perfect. I think we corrected, it said verify that ports on all switches are configured to participate in STP, correcting the errors you find. I think I corrected all of the errors that were access layer switches error or access layer port errors. We converted them over to trunk ports, so everything should be working now. So task number 2, it says spanning tree optimization error. So it says a network engineer has given you the task of verifying the optimization of spanning tree on the network. Compare the configurations on the network switches with the parameters listed in the optimized configuration table and correct any errors you find. Okay, so let's go down. I'm going to move my top left down to the optimized configuration that Boson wants. Okay, so it says all switches running MST with VLANs 1 through 3 being grouped as instance number 1. And it also says running MST with VLANs 4 through 6 grouped as instance number 2. So first, let's just start out with that. Let's make sure all switches are running MST with the proper instances that are supposed to be grouped. So let's go over here to a switch 1. Let's do a show run. We can see all of the output in a running config. So we can see that it does have instance number 1 for VLANs 1 through 3, and it has instance number 2 with VLANs 4 through 6. So that's what we want. Let's do the same thing over here. Let's do a do show run over here. We can see that it has the proper instances and VLANs grouped right there. So that's perfect. Let's do a do show run. And we can see here that it has the proper instances and VLANs grouped. Let's do a show run. And we can see here that everything is correct for our first output. Perfect. Go to core switch 1, do the same. Let's do a show run. We can see that it has the proper instances and VLANs. Perfect. And let's do a show run over here. And we can see that this one has the proper instances and VLANs grouped together. So all of those are good. Now it says on D switch 1, the primary root bridge for VLANs 1 through 3. Well, D switch 1 should be the primary root bridge for VLANs 1 through 3, and the secondary root bridge for VLANs 4 through 6. So I think, yeah, all of our configurations are using the default. No, it's not. So D switch 1 right here, it has a spanning tree MST 2 priority of 28,700 and 28,672. This has some default, well, it doesn't have the default values as well, D switch 2. Let's look at core switch 1. Core switch 1 has some configurations, and it doesn't have anything on core switch number 2. So we don't need core switch 1 to be a backup and or primary. So let's go into configure terminal, and let's do a no spanning tree for MST1 with a priority of 24,576. Let's remove that. Okay. All right, now let's go to our distribution layer switches. And let's do a, we want this to be the primary route for VLANs 1 through 3. So let's do a do show spanning tree VLAN, well, MST1. Let's see. So this is not the root bridge. So it looks like D switch 2 is the root bridge. So let's just confirm that over here. Let's do a show spanning tree MST1. Okay, this is not the root bridge neither. Huh. Okay, let me confirm. Let me just confirm. Okay, so this is not the root bridge either. So who is our root bridge? Let's look. Let's just run this command on all switches. Let's do a show spanning tree MST1. Who is our root bridge? So it's not a switch 1. Let's do a do show spanning tree MST1. It's not a switch 2. It's not D switch 1. It's not D switch 2. Let's do a do show spanning tree MST2. Oops, MST1. So for some reason, this switch is still showing up as the root bridge. So let's do a do show run. Okay. I'm not sure why it's still showing as the root bridge, because I took the configuration off. But maybe I have to, let me just let's do a show run over here. All right. Let me do a configure terminal. Let's do a no spanning tree MST1 priority of 28,672. I want all of my defaults back, and then we're going to configure the proper primary and secondary routes. So no spanning tree there, enter no spanning tree MST2 priority to have 24,576. 24,576. All right, let's go to D switch 1 and take our configurations off here. Let's do a do show run. Okay, let's do an exit. Let's do a no spanning tree MST2 with a priority 28,672. All right, so now let's start on D switch 1. We want to make this our primary, so let's do a spanning tree MST1 root primary. All right, and on D switch 2 or on D switch 1, we want to make it the second. Well, let's just do the D switch 1 for D switch 2 first. So let's go right here. Let's make VLANs 4 through 6 the primary route for D switch 2. So let's do a spanning tree MST2 with a root primary. All right, let's go over to D switch 1 and make it the secondary for VLANs 4 through 6. Do a spanning tree MST2 root secondary. Let's go over to D switch 2 and do the same thing. Let's make it the secondary for VLANs 1 through 3. So let's do a spanning tree MST1 root secondary. All right, perfect. Now it says core switch 1 should be the BTP server for all switches. So let's do a do show BTP status, and we can see that it is the server. And it says all other switches are BTP clients. So let's just confirm that. Let's do a show BTP status. So we can see this is operating in client mode. Let's do a do show BTP status. This is operating in client mode. Let's do a do show BTP status. D switch 1 is operating in client mode. Let's go to D switch 2. Let's do a do show BTP status. This is operating in client mode. This should be operating in server mode, which is core switch 1, and core switch 2 should also be operating in client mode. Let's do a show BTP status, and it is operating in client mode. So all of our VLANs are going to be propagated throughout our network by core switch number 1, and our rest of our switches are going to receive those from core switch number 1 because they're all clients within the same domain, which is Boson. So let's just confirm that D switch 1 is the root bridge for spanning tree MST instance number 1. So let's do a do show spanning tree MST1, and we can see that it is the root bridge. Let's confirm that D switch 2 is the root bridge for MST instance number 2. Let's do a do show spanning tree MST2, and we can see that it is the root bridge for MST number 2. So let's hit grade. Hopefully we did everything correctly. Okay, we have an error on D switch 2. Let's see what we did wrong. Okay. So it wants me to configure a priority of 24,576 instead of having it down at 20,480. I just did the regular spanning tree MST2 root secondary, but I guess it wants it to have this specific priority number. So let me configure that priority to be 24,576, 24,576, 24,576. Let's do a spanning tree MST2 priority of 24,576. Let's hit grade now. And that is now correct. So I guess it just wanted that one value, 24,576 right here, or it wasn't going to let me get the lab correct. So we figured that out, got everything corrected there. Thank you guys for watching this one. I'll see you in the next one.